So Joel, have you seen this news article about this lady that got lost in Australia and lived on lollipops and wine?
No, but it sounds like an ex-girlfriend of mine.
Is she in Australia?
No, I don't know where she is.
It's a international story because I saw it here in America. But this poor lady was going to go visit her mother, and it threw a bottle of wine out of the car, and then got sidetracked and got stuck in the mud and was outside cell phone coverage, so she couldn't reach anybody. She was hanging out there for a couple of days, and she lived on lollipops and wine until they tracked her down via helicopter. That's amazing. People in Australia are tough.
It wouldn't be a bad way to go out, as long as it's a good bottle of wine, I guess.
But the crime scene will look kind of weird. Like, what's all these lollipop wrappers in this wine bottle here?
So one bottle of wine, yeah.
You never know. But all the people I know from Australia are pretty darn tough. So this is another example of Australians that survive some of the worst conditions. And speaking of worst conditions, we have a packed show for you this week. We're not sure how it's going to turn out, actually. It's been kind of a struggle to get this episode out. But we do talk about this week bird detection system that was highlighted in PES Wind and in Copenhagen. So I've seen it in two different places recently. So we talk about a camera system that detects birds from pretty far out, and I actually identifies the species of the bird. So really interesting technology there. And then we look at really the separation of China on the rare earth minerals from the rest of the world and how that's affecting all the other countries involved, Australia being one of them in the middle of this because they do have some of those minerals and processing, and who's going to do all that processing. There's a new place in the United States that looks like it's going to do some rare earth processing, and now everybody's scrambling at the same time to look for minerals that are just the byproduct of mine waste. So not only we're pulling out of China, we're like scraping the bottom of the barrel in some cases to find where these minerals are going to come from. So really interesting discussion about that with Rosemary this week.
So then we're going to talk about the University of Aarhus pioneering another way to break down epoxies. Now, in the last few months, if you follow this as we do, you've heard from Vestas that they've got a solution. This is another one coming around in the same corner of the world, but we'll see how it works. And then as well, Ørsted here in the U.S., down in New Jersey, has, like everybody else, realizes that there's a shortage of technicians. So they are putting together a technician training school, and they're going to use a lot of those technicians, I believe 40% of them, in some of their offshore wind farms off the coast of the U.S.
And then our wind farm of the week is from Germany. So you can stop writing me and send me emails asking to have a wind farm of the week outside the United States. We're in Germany this week, and a lot of interesting things happening in wind in Germany. So listen to the episode and you'll find out who it is. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with the vice president of North American sales for Wind Power Lab, Joel Saxum, and the Bill Nye of Australia, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. Joel, when we were over in Copenhagen, I came across this company that was showing and had a booth called Nvisionist. So I just took a quick look at it, and it's one of those bird detection systems. And I thought, wow, that's kind of cool. And it's a camera-based system. And from what I could tell, it looks like when you see the Tesla car in full self-driving mode, and it shows you like there's a dog, there's a bicycle, there's a bus, there's a crosswalk. It's detecting birds in that similar fashion. And I hadn't seen these systems that close. I thought they were a lot, just sort of old technology, but they're not. They're like AI-based systems now.
Yeah, there's a couple of them out in the marketplace as it sits. I know there's one that's been around for probably 3 years now, called Identiflight. But they're all working on the same premise, right? So you can use an AI model or train an AI model to recognize most anything, right? The earliest AI models of what we know of AI right now is like OCR, If you've ever used Adobe products, you know what OCR is: optical character recognition. So it just scans through it and it recognizes what it's looking at by looking at being trained on enough letters. It knows what it is. So same kind of thing. But it's with the advent of all these like NVIDIA Jetson TXI chips and stuff. Now I can do this computing on video frames at the edge. So now you're imagining like this camera looking out there, and it might be at 24 frames per second, might be at 8 frames, 16 frames. I don't know exactly what they're at for processing speed, but sometimes it will take a video frame or a video feed that's at 24 frames per second, dumb it down to say 4 frames per second. So every second you're processing 4 pictures with an AI model to see if there's a bird in it. And then it's not only is there a bird, it's what kind of bird it is, right? And that's the big thing here, because sometimes there's a certain species that can't, you have to make sure you curtail for. I know, like in Germany, there's a certain kind on the coastlines. There's a certain kind of goose that when that goose is in the area, you got to shut the turbines down, or at least that was a rule a year or two ago. So in the U.S., you may have, the states don't normally have individual laws on taking birds, but if it's a migratory bird, then you run into federal law. Same reason, like if you're out duck hunting, you got to have a federal bird stamp because it's across the state line, so that's controlled by the feds. So the species identification is important, right? It's not only the birds though as well. It's what direction are they flying in? What habits do they have, right? So I also Wind Power Lab a few years ago was involved in a project called the Beacon project. It was with University of Aarhus, someone's PhD project, but we used radar, and we had basically recreational boat, like civilian grade radar, one in a horizontal plane, one in a vertical plane, and with those spinning, it created a dome of radar coverage. And once you had that dome of radar coverage, then you could get the signals in as a raster signal to what birds were flying through the area. And by what birds were flying through the area, you could track patterns, and even kind of see what species they were, which is an odd thing to think about. But eagles fly a certain way, ducks fly a certain way, right? Like the way they circle, the way their wings move. So you can start to identify species by radar that way. But identifying them with a camera is much more high resolution, right? It's a lot better. But yeah, I mean, it's needed. It's needed in the marketplace.
Yeah, and the nvisionist system that I saw, they had a little YouTube video. It sounds like there may be a couple of different variations here, because I read about one that was mounted on top of the nacelle, which makes sense because you can see 360 around you. But they also showed one that was mounted to the tower, so it's actually has 2 cameras real close together to give you binocular vision, essentially, right? So you can tell how far something is away. And they use that to, one, detect and figure out what these birds are, and then to slow the turbine down if the bird is coming in too close, so they can really gauge a distance on whatever this bird is. But on offshore systems, where they have, I assume this is because they're using bigger turbines, they actually add a radar to it, so they can see like 10 kilometers out from the turbines, and then there's a kind of a graduated system. They can track it for further out, and as the bird moves in, they'll start to slow the turbine down, maybe even stop it in some cases. And I couldn't figure out what was driving to have a radar system offshore versus onshore. Does it have to do with like the amount of time it takes to slow the turbine down? Those big offshore turbines can't stop on a dime, right?
I would say 2 things. 2 things would be, of course, that, right? It's a lot easier to stop a turbine with 35-meter blades than it is to stop with 100-meter blades, right? Just that rotational mass. And you're not hitting the E-stop button, boom, because you're going to blow the gearbox up. So we're not going to do that. But another one is, of course, offshore visibility, right? So when you have any kind of cloud cover or fog cover and it's a lot more common, you can see through that with radar, and you can't see through it with an RGB camera or a FLIR camera. So I think it's a combination of the 2 of those, and because you get that further range, so when things are coming, you can start to curtail or slow the turbine down, because you're just not going to get it stopped in time if you try to stop it too quickly. And then it's weather.
In that case, where we're getting to the point where this technology is readily available, do we start putting these systems on on a lot more turbines. I don't think they're on that many right at the moment, except where it's required.
Yeah, it's going to be driven by legislation. Again, it's just like last week we talked about the red lights in Nebraska. Nobody's going to pay the $2 million to put it out unless that from a capex standpoint at the beginning of the jobs, there's a stakeholder within the area that wants and demands this to happen. That could be, or if it's just driven by regulation, right? The example that I said earlier about the geese in Germany, that's a regulation. That's what part of that Beaker project was this certain species we needed to curtail for, so we avoided it. In the U.S., I think you could possibly see it for raptor populations, raptors being eagles, owls, those kind of predatory birds.
10 years ago, I would never thought that this system would have been available, right? To be able to detect birds from that far out and to identify them as a bird and what species of bird that it is pretty remarkable, right? And what's coming over the next couple of years will be even more interesting, because my guess is the price goes down, right? The system performance goes way, way up, and the price comes down, where you may see widespread usages of these systems. It's good.
If you follow I know a lot of people in the drone world will follow this stuff, but it's a combination of edge computing devices and cameras. So as cameras get better and better and better, when the first Zenmuse X30 camera came out for a drone, it was like $15,000 for this camera that could zoom optically 15 or 10 times and digitally 20 times or something. I can't remember exactly what the details were. And people were, oh my God, this is amazing. If we can get this for inspections. Now that camera's like $2,200. And now the next one is the P100, where it's like 100 megapixel drone images, right? So, and then the edge computing, where edge computing was super fast 2 years ago, that edge computing device that was the size, a chipset that's the size of your cell phone. Now you can do that same thing with someone the size of your fingernail, and the one that's the size of your cell phone can compute 10,000 times the data. So the changes are so fast.
Just leveraging the same technology, right? Are we able to detect whales on the east coast of the United States? Just say if they're mounted on top, right? So I know these systems are kind of looking up to the sky looking for birds, but can they also not look down and say, hey, there is a family of whales scooting through the area?
Put a polarized lens on the RGB camera and you'll be able to see through the water.
That's what I'm saying. Yes.
The other thing is use the same technology that like the Wind Power Lab did, the Beaker project. It's just running AI algorithms on radar feedback. Radar feedback is the exact same thing. Radar backscatter is the exact same feedback you get from a sonar that works subsea.
Oh yeah, sure.
So you can run an AI model and detect a whale off of sonar by running an AI model against it. It's all doable.
On the nvisionist website, they had a discussion about older technology having to basically block off parts of the camera's vision system to say, oh, there's a road over here and there's a bunch of trucks coming down and we don't want that to trigger this system. So let's block it out and just cordon it out. But now with this new technology, they can detect the trucks and say, hey, that's a truck. It's not a bird. No deal.
No big deal, because the processing speeds are higher, right? So if you know anything about video compression works this way. Frame to frame, you may have 30 frames per second, so 30 images per second. If that value doesn't change from frame 1 to frame 2 to frame 3 to frame 4 as a color value, they just store that as one unit. Right. That's why when you're on FaceTime on your phone and you're moving all over the place, if you have a bad internet connection, you'll start to get choppy. But if you slow down and just stare at it, you'll get clear again. Right. Because it's video compression. It's the same thing that the edge computing devices in these old technology ones did not have the power to process moving cars and all this stuff at the same time. It just wasn't enough. You'd go from being able to process 10 frames a second to being only able to process 1 or 2. And then you can't really process video that way. So now that the edge computing devices, these chips, are getting so powerful, you're able to do AI recognition on all these things simultaneously, because you've got the computing power to do it.
That's amazing technology. Well, there's more to come in the space. There's some articles out today, and I didn't have time to gather enough of them up for this podcast, but some more recent research saying more bats were killed than birds, and maybe I ought to focus on the bats a little bit. That's probably true, right? But you got to give technology time to catch up. We're definitely in the catch-up game. So more to come, and this nvisionist system is pretty cool. Hey, Uptime listeners. We know how difficult it is to keep track of the wind industry. That's why we read PES Wind magazine. PES Wind doesn't summarize the news. It digs into the tough issues, and PES Wind is written by the experts, so you can get the in-depth info you need. Check out the wind industry's leading trade publication, PES Wind, at peswind.com. There's multiple news articles, not in like the New York Times or Washington Post or Wall Street Journal here in the States, but there are a lot of sort of low-level news articles about rare earth minerals and the soon-to-be departure from China in that space in terms of providing or selling those rare earth minerals to the United States and Australia and a number of other places. So China is reportedly considering a ban on the export of rare earth magnets used in electric vehicles. So Elon Musk, look out. Also in wind turbines, motors, and other products. This comes amid growing tensions between the U.S. and China and a global shift towards decarbonization and the use of electric motors. China currently controls about 90% of the market for samarium cobalt magnets and roughly 84% of the market for neodymium magnets worldwide. If China bans the export of these technologies, it would become difficult for the U.S. and Europe both to enter into the market and to make them, which makes us basically totally dependent on China at the moment. So as China goes through this process of slowly banning the United States and the rest of the world, they're talking about national security. Why would we send these magnets out to someplace else that doesn't like us? And America would do the same thing, quite honestly. So this is the start of a mineral war, basically, right? We're not shooting at one another, thank God, but we're restricting natural resources from one another. And so that puts Australia, Rosemary, in a unique position, because if China decides to stop on some of these rare earths, I think the next place to go is Australia.
Yeah, I think that's likely true for rare earths and other critical minerals, probably more so other critical minerals where Australia's got the kind of unique advantage, because rare earths, despite the name, aren't really rare. They're kind of distributed all over the planet. The problem is that they're not very concentrated. There aren't many sources where they're very concentrated, but there's a lot of interesting work in Australia and elsewhere to try and find new sources of rare earths, because we have been just relying on China. Like the whole world has just been relying on China for rare earths. So yeah, I mean, there's a bunch of different ways that can take. The most simple one is just substitution. At the moment, we use rare earths when you want to make a really, really strong magnet, basically. And you'll use that in electric motors and generators. And I don't think that there's many rare earths used in onshore wind turbine generators, but offshore, when they're trying to keep the size of the direct drive turbines smaller, then you use rare earths. A stronger magnet can give you a much smaller size. But yeah, for sure, we already know how to make generators without them. There's just, benefits to using them. And I did see in the news recently that Tesla is planning a new kind of motor that doesn't use rare earths in an attempt to get away. And I've noticed that that's something that they've been pretty good at doing, foreseeing potential bottlenecks from, certain problematic materials or components as well. Like they didn't suffer as badly in the computer chip shortage because they were in control of their supply chain and they just found a different way around it. We've seen, cobalt is another critical mineral that has supply chain problems. It's problematic that most of it comes from Congo and has forced child labor and other human rights problems associated with it, and environmental. So Tesla, amongst other manufacturers have moved away from using cobalt at all in some of their batteries. So you can move to the lithium iron phosphate battery chemistry, and that's what all of their batteries, maybe paradoxically, all of the batteries that are made in China are of that chemistry, and that's what we get for the most part in Australia. It's just got a little bit less energy density, so batteries are a bit bigger, a bit heavier for the same storage capacity. And then, now this third example that I've noted, that they're moving away from rare earths in their motors, or they're trying to. So that's the most simple thing. There's other ways to get your hands on rare earths as well. I think in the past, they've all come out of China. It's been kind of a bad deal for the rest of the world, bad deal for China as well. Like, both people got bad parts of the deal. So for the rest of the world, we've lost the ability to, control that part of the supply chain, critical part. But from China's point of view, they were able to, lock down that mineral or those minerals by providing them very cheaply. But the thing is that when you process rare earths very cheaply, you usually get a lot of radioactive byproducts. And so I know that there's been reports of, some of the villages that are downstream from the processing of rare earths in China have very, very, very high rates of cancer and, like a lot of environmental destruction. So, there's been a heavy price paid there too. So I think that when we are moving away from China processing these materials, I mean, it's either we've got to accept that kind of environmental and health impact everywhere that we process them, or we have to accept a much higher cost for them as we process them without those issues. And for sure, you don't have to accept that, but then you have to pay more. So that's the bargain that we've made in the past. We got cheap minerals that we couldn't control the supply chain for, and China got they locked down that part of the supply chain and got the, economic benefits. But on the other hand, they've had health and environmental problems. So let's see, engineering is full of hard trade-offs like that, and you kind of have to accept that moving forward.
It's odd that you don't read a lot more about this. And Australia is really stepping into the breach between the United States and China on minerals, and some news articles here. So Australia supplies nearly half the world's lithium and is the third largest cobalt exporter, and also is a significant producer of things like copper, graphite, manganese, and other minerals that we really need in this green transition. While the Australian government has signed some new agreements with Japan and Germany and the UK and India since late last year, and is encouraging funding for project development. And Australia is going to release its own national critical minerals strategy. Now, this is really telling, I think, because when Australian politicians call out specific countries, I think that's unique, particularly if it's China. And there's an interesting quote here from the Minister of Resources, Madeleine King. Quote, "China enjoys an unchallenged position across many aspects of the global critical minerals market, having invested in its sector for decades. Like-minded partners can work together to build sustainable supply chains and hedge against such concentration." So Australia is saying, hey, we're here. and we can provide some of these minerals that everybody needs for this clean transition. If China's not going to do it, we can do it. And I think that's going to happen. It has to happen. Like you said, Tesla's moving away from some of these critical minerals. I've noticed other motor manufacturers, I think GM's talking about this too. Some of the car manufacturers are trying to get out of the China business in terms of relying on them, because it hurt them so much during the COVID pandemic that it's a natural transition, don't you think? It was going to happen after COVID anyway, but now that there's any sort of impasse between China and the rest of the world, it's going to accelerate that.
Yeah, I mean, I think it was obviously stupid to rely on one country for so many critical things. And I know it was an intentional strategy from China to, get into the technologies of the future. And they accurately foresaw that batteries were going to become very important to a lot of people. And so they, doubled down on making sure that they were the supplier for most of the critical materials from there. that are used in batteries, sorry. But they're not blessed with the raw materials. They don't actually have the minerals in the ground in China for the most part. They do have some of most of those minerals, but for example, the lithium isn't high grade enough that they could produce it economically from China. So they've looked to elsewhere, and I think virtually all of Australia's lithium goes to China for processing. I don't think there's much going other places. And so, it's a two-way relationship. And for all of these things, I'm just kind of getting into the mining industry myself. It's actually good timing for this episode because I'm in Brisbane at the moment for a company that I work for doing minerals processing. It's a startup, and we're trying out some new processes and building a pilot manufacturing facility here. It's kind of like halfway between a lab and a full-on mineral processing plant that's designed to be very flexible so that you can lock down new processes. And so it's something that I think for a long time in Australia, a lot of us have been really frustrated by the fact that we've got so many mineral resources here, and in fact, Australia I think is the only country that has all of the 10 minerals that go into making a battery, and a lot of other things as well, especially iron ore. A lot of our economy depends on iron ore. Aside from the fossil fuels that everyone's well aware of how much money we make from those, but at the moment, we dig up the rocks, lithium rocks, dirt for iron ore, and we just ship all that to China and they process it, and it's just and all our mining companies are foreign owned, and so the profits just go offshore, and it's crazy. We benefit so little actually from our resources. So well before battery minerals were the trendy thing. I shouldn't say trendy because it's a legitimately critical thing, but everyone long before everyone realized that, it was clearly a waste that we're doing just the dumb low value add part of the process and then sending it offshore for them to do the high value add parts of the whole manufacturing process. And so it's really exciting now. There's this opportunity, and the IRA is a large part of that. We're fortunate that we're, a country that America is best friends with, that has all this stuff, because that political tie is a key part of it. But now between that and the Australian government's own plans for critical minerals, we're at the point where I think we might actually have the opportunity to really change the mining industry and start to process here. There's so many benefits from it, not only economic benefits, because it is, like I said, it's like the high value add part of the process to go from the what you dig up out of the ground and then process it into the actual minerals that people need. But aside from that, you also have some environmental benefits. One, from it happening in a country that has pretty strong environmental protections, but also because you can imagine to ship a whole bunch of rocks and dirt for somebody else to process, that's a lot more ships that you have to send than if you would actually make chemicals and steel, for example, and ship that instead, and not ship all of it, because presumably some of it we're going to use in Australia. So benefits all around. The other key piece of the puzzle that I haven't mentioned yet is that Australia has the potential for so much more renewable energy than we could ever use here, and so a lot of this processing and manufacturing, it's really, really energy intensive, and so we got that last piece of the puzzle to be able to fit it all together. We've got everything that we need here to take it a bit further. Get more money, better for the environment. It's just, you can probably see that this is one of my pet topics that I've been complaining for probably literally decades about why we don't do this. And I'm kind of really excited that I finally seem to be in the right place, the right time to help out with the transition away from just dumb digging up stuff through to actual I don't know, advanced critical minerals industry.
Well, it does seem like there's becoming more of an engineering consensus on the things that are mined, even in Australia, that maybe some of the money is not actually in the mine itself as much as the byproducts from the mine. And there's some really interesting news stories about this recently. Sweden, South Africa, and Australia are leading the charge to turn mining waste into rare earths, reducing the dependence on China. Again, right? Trying to remove reliance upon China. So 6 advanced projects are being developed to extract rare earths from mining debris or byproducts, targeting output over 10,000 tons of key elements, neodymium and praseodymium oxide by 2027. The projects could cut the expected deficit in the materials by upwards of 50%. So just going by and just looking through the excess of the mining operations, you can gather 50% of the minerals you need, which is shocking. That's really high. Recovering rare earths from waste is much quicker than setting up new projects and trying to dig a new hole and try to find this stuff. So obviously, if you're sitting on the sidelines, you can just process it. Companies can extract phosphorus for fertilizer, fluorine, gypsum, and other rare earths from mining. The byproducts, and this is really going to be key to keeping rare earths available in the near future. So there are some new processes that are being developed to extract these minerals, including ion chromatography, and which is used in the pharmaceutical industry. And there's some technology around some scientists from MIT. But as things progress here, you're going to see more people going back to the tailings, right? I mean, that may be where the money is. It's in the tailings rather than the thing you're actually mining.
Didn't we, correct me if I'm wrong, with these last few things we've been talking about here with rare earths, didn't we a couple months back talk about a company from Michigan that was developing a turbine that didn't use any rare earths minerals?
Yes, it's a generator that had a different design, different layout to make it more compact without using a lot of rare earths. That is still in play. I have followed them occasionally. It's been a couple of weeks since I looked, but there is efforts because obviously if we're going to put up another 120,000 wind turbines over the next couple of years in the United States, you're probably going to have to change the way we build those generators, right? And even some motors. And it's more of a pancake generator or a pancake motor. Everything is flatter. It's a different way of moving the magnetic fields around a generator. That's what their thought process is. And I think you'll see both, Joel. I think you'll see less reliance on the more powerful magnets and maybe a switch over to some new technology, which is where we should go. As part of this withdrawal from China and finding all these minerals, you need some place to process them. And we do not have a place to extract these rare earth minerals in the United States, weirdly enough. But we're working on it, and we're going to build a plant in Louisiana. The first rare earth extraction and purification plant in North America will be built in Alexandria, Louisiana, following a $75 million investment at England Air Park. The UCOR North America plant will create 100 direct jobs and almost 300 indirect ones. The plant will operate in an existing 80,000 square foot building at the air park and begin operations in early 2025. So they got a short time frame here, with the capacity to process over 7,500 metric tons per year of rare earth oxides by 2027. So what they're hoping to do is Alexandria in Louisiana is kind of along a river where they can bring materials in and out and process them. And so they're essentially going to take the tailings and all the runoff of some of these mines and process them to get the rare earths out of them in Louisiana, of all places.
Unless they're getting the raw materials from somewhere in the Gulf, I got a hard time believing this is a financially sound move.
I don't think so. I think it's part of just having security. Don't you think? Don't you think that's what's going on?
Yeah, but if that's the case, then it's got to be subsidized, right?
Yeah, it didn't say what the prices were for the products they're going to be selling, but I'm assuming that you're going to pay a little bit more money to have it resource in the United States.
It's an interesting way to do it. If the idea is that they'll bring in mine tailings from around the country and process them to get the rare earths out, and then send them off. The model that the company I'm working with, it's more geared around, you're probably going to be setting up small plants at a specific mine, because part of the benefit for using tailings, mining waste as a source of new minerals, is that you have to pay to dispose of that anyway. So if you process it first, then you have to dispose of less mining waste, or you're saving at least one lot of waste disposal. But if you have to take all your waste, transport it a long way, then process it, and then they'll have to deal with their waste, then you're still doing that twice, which gets rid of a lot of the benefit of using mining tailings.
So here's a quote from the plant director. It says more than 90% of the rare earth processing happens in China, like we've just discussed. And Ucore's plant will handle rare earth element oxides from, quote, U.S. friendly sources all over the world. And I assumed that was Australia when I read that.
Everybody but China and Russia?
Right, yeah. Yeah, but isn't it weird? We do not have any rare earth processing plants in the States. We're a big country. You think you'd have one.
That's weird to me. Because in the Nevada desert, there's lead, silver, lithium, gold. Like, they're mining all kinds of stuff out there. You can't be telling me that there's nothing out there that they're mining.
There is a rare earth mine in Nevada that I think it was operating, and I don't have the figures here, but I think it was operating in the 70s or something, at least a decade or two ago. And they're starting it back up again, but maybe they're not planning to process there. It just seems strange because they're in such low concentrations, the rare earths, basically anywhere they're found. So it would seem really weird if you were just going to, you have to do some sort of processing surely on site. Otherwise it's just crazy volumes that you're going to be shipping. But yeah, it might just be some processing, some last bit of processing happens at this new plant that doesn't involve such large volumes. You'd have to see the details.
Rosemary, I got a question for you. So when we talk about rare earth minerals, because this subject has come up a few times, I think that the term, from listening to your knowledge on it and your technical expertise, the term rare earth seems to be a bit misleading. What would you actually call these minerals? Because it seems like they're kind of everywhere, but they're in low concentrations, right? What would you call them?
Right, like lithium.
Yeah, would you call it like maybe not rare earth, but like low concentration?
I don't know what the right name for them is. The most annoying thing with the terminology around rare earths is that now everyone uses the term rare earth to mean nearly anything. So I heard somebody say recently, rare earths like copper. Copper is not a rare earth. There's a specific set of elements that the term rare earth refers to. Yeah, I think critical minerals is a nice term. That's I think we should use that. It's already like a pretty. It can refer to whatever you want. It's stuff that you need and you find hard to get. That's all you need to fulfill to be called a critical mineral. So I guess I would, just like to get people using the term critical mineral more than rare earth. But I guess rare earth is more catchy or something. I'm not sure why, but I see a lot of people calling things rare earths that really are, just critical minerals.
In America, we like to make words as short as possible, right? Rare earth is a lot easier to say than critical minerals.
Well, you like acronyms in America, so maybe you can just call them CMs or something.
But they have to be 3 letters.
REM.
REMs. There you go. Rare earth minerals.
But we don't want to call them rare earth minerals. We want to call them critical minerals so that, it's broad enough that people can use it correctly. Literally, I think that is the problem, that it just doesn't sound as cool.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
Researchers at Aarhus University in Denmark have developed a new method of breaking down wind turbine blades so that their component parts can be recycled. The challenge of recycling the blades, of course, lies in the fact that they are built to last forever, which means that the materials used to create them, such as the epoxy resin systems, cannot currently be recycled. Well, researchers have developed a process that targets the chemical bonds in the epoxy and breaks them down while leaving the glass fibers intact. So you don't have to grind everything up and try to break it apart. You just sort of leave it like it is. The team used solvents and a catalyst to break down the epoxy materials, heating them to about 160 degrees Celsius. And Joel, that's about 350 degrees Fahrenheit, something like that. And they had to leave it between 16 hours and several days. After 6 days, a 1-inch square chunk of wind turbine blade was left nearly spotless in terms of its glass fibers, and the epoxy was broken down into its constituent parts. So they thought, okay, we got a system here. It may be a little take a lot of heat. It may take a little bit of time, but it will work. So although the method was able to break down the materials in the lab, could be difficult to scale it up and to make a real dent in the amount of wind turbines that are going to be decommissioned over the next 15, 20 years. And one of the possible roadblocks to this commercial operation is the catalyst used. And then they were using ruthenium. Now, the ruthenium wasn't used in the process. They could pull it back out, but doing that makes it obviously more expensive. So it seems like they found a chemical way of breaking down epoxy systems, but it may not be the way that the industry wants to do it. It's going to be expensive, right? So there's another team working on this, which is from Vestas. I think Vestas has been working on this problem for a while. Vestas has a different process, but they haven't really defined it. And from what I could see online, it's not going to be defined for a while. Like they're out rushing around trying to patent it, or they're trying to put some fine details on it. So now essentially we have two different ways of recycling blades to get the parts back out. You have fiberglass, and from the pictures I saw from these researchers up in Denmark, it is fiberglass. It doesn't seem to, this chemical process doesn't seem to affect the fiberglass at all. It isn't like it's burnt or charred or anything. And the epoxy system is broken down into its parts, right? And the most expensive part of epoxy is the bisphenol A part. So if you can get that out, you have something of value. And obviously fiberglass can be a little expensive. So you do have some valuable parts to this. The question is, does the process lend itself to actually recycling blades with standard epoxies?
I think, and Rosemary's probably much more of an expert on this than I am, but when I look at, I don't know how big of a piece they put.
It's like a 1-inch square chunk of wind turbine blade they put in a beaker and heated it up. And
I don't see that as a sustainable option, right? It's too resource intensive to make happen. I mean, you can cut up wind turbine blades into pieces, put them in there, try to extract some of the raw materials out of them. But too much energy is going to go into heating the material. Too much that ruthenium, as we talked about earlier, possibly a rare earth mineral.
Well, that's just the thing, right? Rosemary always points out it's not just the process; it's all the stuff you have to do to get to the process, right? So you have to transport, I guess, a full-size blade to a recycling center. Because as soon as you start cutting it up, you're cutting up all the fiber that you're going to need, right? Because the fibers run lengthwise on the blade. So you're going to cut them up and make them kind of worthless at that point. But you got to truck these heavy things around. That's got to be expensive. Chopping them up is probably easier. I think Rosemary's point a good number of times is just bury the thing. Why are we not burying them? And that's a valid point, because it's probably less CO2 emission over the lifetime of the blade if you just bury them.
Yeah, I think for now, burying them makes sense in a lot of places. But I do see that this process does legitimately look interesting in a way that most of the recycling methods that I've seen so far don't. So if it's just been published in Nature, let's say that it's going to be 10 years at least until we're going to be putting, processing whole blades with this. Is a long way from 1 inch to 100 meters or even 40 meters. But there's a lot of potential in it. So they're actually separating all the components. They're not just finding a way to hide bits of wind turbine blades in other materials, which is what most of the recycling that we've seen so far is. Or I guess the first way that people are, recycling wind turbine blades is just to burn them, which releases carbon dioxide into the atmosphere. So it's not amazing. And then you can already, shred wind turbine blades and get some sort of structural properties from using that shredded material in other stuff. So, you can make like decking material out of that, or dashboards, molded plastic dashboards for cars, or trays for trucks can be made out of that sort of material. So, it's got some value, but not much compared to how much it costs to actually, reprocess that. And it's usually more expensive to use a recycled wind turbine blade than to just use virgin materials. So that's not ideal. But this one, they're not only pulling out the glass fibers with their structural integrity intact, which I have seen before, but they're also separating the components in the epoxy resin so you could use them again. Because a wind turbine blade, it's mostly made from fiberglass. And yes, the glass part is important, that's in the name, that's what people think of, but the epoxy is half of it, roughly, and just as important. And so if you're only reusing the glass, you can't really say that you're recycling fiberglass. You're just, using some of the glass. So for now, then they mentioned, and I just wanted to say as an aside that I like this article because it actually gave enough details to comment on. It's nearly always when we have these stories come up on the show, it's like, well, I don't know what's going on there. Who knows if it's good or not. But in this one, they mentioned a lot of inputs that it needs, and the materials input is one thing that you mentioned, though they are trying to separate everything out so they wouldn't be, buying more and more and more catalyst, or at least not a lot of it. Energy input is a big one, and I know that with a lot of existing plastic recycling processes for the difficult to recycle plastics, sometimes you end up using more energy and having more carbon dioxide emissions from the recycling process than if you had just gone from virgin and then put it in landfill later. So that will be a key point. But by the time the process is ready, no doubt, all of all of our energy or industrial heat will come from renewable resources anyway, so it won't be such an environmental burden. But I think definitely this is one to watch. Let's see how it gets commercialized. It may be that you don't need to chop blades up and chuck them around. Maybe they'll refine this process so well that you can just take a mini plant out to a wind farm that's about to be decommissioned, feed a blade along a conveyor belt, and it's spraying these chemicals down, and by the time it gets to the end, you've just got all your fibers in the same length that they started, and who knows where we're going to be in 10, 20, 30 years. But in the meantime, I do think that it's not a bad thing to store all of the wind turbine blades underground in what we call landfill, but you might call, storage for, while you wait for the recycling processes to be developed.
Yeah, we could ship them to Wisconsin and call it cold storage.
I think we could make some offshore reefs with them.
We could. No, that's actually not a bad idea, really.
Or like weather, like breakwater, right? Like, so you protect some ports and things.
All right. Yeah. Well, this week, Vestas released its financial report for quarter one, and they made about $17 million. They had positive cash flow in the first quarter, Joel, versus I think last year, same quarter, they lost, I don't know, $500,000, $500 million. Sorry, $500,000 would be nothing. $500 million is the right number. Yeah. So they had a slight positive growth, which is a change. But it just reinforced in my head, like there are so many things that the OEMs have to deal with simultaneously, where they're getting their minerals from, right? And so like Siemens, Gamesa, and Vestas, and all these companies are running around trying to find where they get their rare earths from. They're trying to deal with the recycling bit. They're not making a lot of money. So they're trying to turn the companies positive. And another thing that is coming about in sort of the large operator side is in the States is they don't have any trained technicians. They're having to run training programs. All these large operators are creating these programs. Well, Ørsted announced another one. So renewable energy company Ørsted just has launched its Wind Power Ready training program for wind farm technicians at Carnegie Library in Atlantic City. So if you haven't been to Atlantic City, it was at one point, maybe 20, 30 years ago, a big kind of casino place like Las Vegas is now. But
Boardwalk Empire, right?
Yeah, and that's fallen off quite a bit from its heyday. So the Ørsted program aims to partner with local organizations near Ørsted's developing offshore wind facilities throughout the U.S. to provide individuals from underserved communities with a pathway to a well-paid and permanent career in clean energy. So the whole thing is at least funded through grants from Ørsted and the New Jersey Wind Institute for Innovation and Training and the New Jersey's Governor's Office for Climate Action and the Green Economy and the New Jersey Department of Environmental Protection. So it's like Ørsted and a lot of New Jersey government arms. Ørsted plans to hire about 40% of its technicians for Ocean Wind 1 project from the training program. So you think about all the sort of balls you have to have in the air if you're an OEM and if you're a large operator, you have to basically create everything. You have to train the technicians. You got to do all the licensing. You got to explain how this works to the U.S. government on how you're going to build offshore wind because they don't have any idea. For the most part, it's coming over from Denmark and the UK and France and other places. It's just there's so much on their plate. In fact, Siemens Gamesa, the head of Siemens Gamesa, talked about recently about building new factories because he was questioned about building factories in like Australia, Rosemary, or Brazil. And he said, we're probably not likely to do that because a new factory costs upwards of 500 million euros. Like, wow. So not only are you trying to expand your business, in order to do it, you have to spend 500 million euros to open a factory. And then if things kind of go sideways, you may have to close that factory.
Yeah. What do you do?
Yeah, right. What do you do in that situation? I think weirdly enough, and this I was out back mowing with my battery power mower over the weekend, thinking about this, like they got one of the worst jobs in the world. There are so many things they have to do simultaneously, and everything has like, a $1 billion sign behind it, right? Almost everything does. It's insane.
The whole world is looking at basically what, five, if you count the Chinese manufacturers, five or six companies to make this happen, right? Three of them in the 3 or 4, 3.5, 4 in the Western world, 5 in the Western world.
It's almost impossible. And Joel, today I was just thumbing through some, because we had been to Norway recently, I was just seeing what's going on in Norway. Well, Norway's talking about taxing onshore wind with a tax of about 40%. Like, what are we doing? I don't understand what we are doing right now because the OEMs aren't making money. They're trying to make decisions about what's happening in the future. They're being asked to do more and more things simultaneously. Like, can we just take the boot off their neck just for a brief moment? Can we do that? And Rosemary, you were inside of these companies. I know you didn't work at you worked at LM Wind Power. It isn't like they were flush with cash and you guys were having caviar for lunch every day. That wasn't what it was like, right? It's a tough work environment.
There was caviar on occasion, I will have to admit. But I mean, there's caviar and caviar, right? Like it's not such a weird food in Denmark actually. So yeah, no, there was on occasion fish eggs. Let's call it fish eggs so that it doesn't sound so fancy. But I can't lie and say that there was never caviar in the canteen at LM Wind Power. But no, I can confirm it wasn't flush with cash. I just want to get that out there. Like everybody, take a deep breath a minute. GE's trying to make money. Vestas actually did turn it around. GE's trying to turn it around. Siemens Gamesa is trying to in this turnaround project. Can we just help them just for a brief moment? Because otherwise, this is not going to happen. It's just not going to happen. Our wind farm of the week is Reinschardswald Wind Farm, which is located in central Germany. Now, Joel, from what I could tell online, this is where some of the Grimm fairy tales are based, is around this area in sort of central Germany. So this wind farm is sort of like in the dark forest area, I guess. It's fascinating.
we were just over there in Hamburg not that long ago. Yeah, we had a great, fantastic time there. Yeah. Well, in this Rheinschwarzwald wind farm, which I know I have murdered, so please do not write in. It's a 100 megawatt project using 18 Vestas V150 5.6 megawatt turbines. And the project is underway at the moment, and it's supposed to complete this year. It's expected to power 105,000 households. And the cost of the project is about $160 million. So this kind of relates to Phil's $1.6 million per megawatt installed. That's so Phil Tataro's right on the numbers part. So this is we're trying to expand our wind farm of the week outside the United States, and I have to make a request to Europe. You need to write something about your wind farms, because in America we got PR departments that write about their wind farms every week and put out some really cool videos. But in other parts of the world, this isn't happening. So I'm having a hard time finding some of these wind farms. And this one at least has written something up about it lately.
You know what GDPR is?
Yes.
That's why. Nobody can, it's too hard to talk about. If you have a technician in your video, you have to get him to sign off on GDPR laws and all these different things. It's a pain to collect content over there.
Well, it makes it hard to promote wind energy in Germany if you can't talk about it.
That's true.
We're talking about it. That makes one. I guess we can do whatever we want in America.
We're not under GDPR law.
We're barely under any laws at the moment.
That's true.
So Rheinschwarzwald Wind is our wind farm of the week. That's going to do it for this week's Uptime Wind Energy podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy podcast.